Imagine waking up tomorrow and the sun is just gone. Total darkness, freezing cold, the Earth turning into a dead rock in space. Just thinking about it feels depressing, right? Our sun is powerful, yes, it lights our days and keeps us alive, but compared to other stars, its story is kind of boring. The shocking truth? Some stars don't just die quietly. They go out in ways so violent they can reshape entire parts of the universe. Section 1. The quiet sun versus the dangerous stars. Our sun is like a responsible office worker. It'll burn its fuel, shine for billions of years, then quietly fade into a white dwarf, a small, dim remnant. Nothing too dramatic, nothing that would shake the universe. But other stars, much bigger than ours, 7, 10D, and even 20 times the size, their endings are pure chaos. These giants live short, intense lives, and when they run out of fuel, they collapse and explode with unimaginable force. The difference between our sun and those monsters comes down to one thing: mass. But how can a single number decide a star's fate? Enter the Chandrasekhar limit. A small number with a huge consequence. 1. 4. That's it. A tiny number with cosmic power. If a star's mass is less than 1, 4 times the mass of our sun, it can die peacefully, shrinking into a white dwarf. But if it's more, gravity wins. No excuses, no mercy. In the 1930s, a young scientist named Subramanian Chandrasekhar shocked the physics community with this discovery. Many laughed at him at first, but the universe itself proved him right. Any star heavier than that limit will collapse under its own weight, with gravity crushing it beyond recognition. But why do stars fight gravity in the first place? The answer lies in nuclear fire, the eternal battle in a star's core. Inside every star, there's a constant war. Gravity tries to crush it while nuclear fusion pushes outward, keeping it alive. Fusion is when hydrogen atoms slam together and merge into helium, releasing insane amounts of energy. Einstein's famous equation, E = mc2, explains why. Even a tiny amount of mass becomes a staggering burst of energy. Think of it as billions of little nuclear bombs going off every second inside the star. That's how stars hold themselves up, and how they shine for billions of years. But humanity didn't just sit back and watch. We tried to copy that power, from starlight to superweapons. After World War II, the US and the Soviet Union started a deadly race. Could we harness the same reactions that fuel the sun and turn them into weapons? The first nuclear bombs, like those dropped in 1945, were based on fission, splitting uranium atoms to release energy. But the hydrogen bomb? That was a whole new level. It used fusion, the same reaction inside stars. In 1952, the US detonated Ivy Mike, the world's first true hydrogen bomb, releasing a yield millions of times greater than Hiroshima. A year later, the Soviets followed with their own test. Humanity had stolen the fire of the stars, but turned it into our most destructive weapon. But what happens when a real star runs out of that same fuel? The answer is terrifying. When the fuel runs out. Picture a massive star burning through all of its nuclear fuel. No more fusion, no more outward push, nothing left to fight against gravity. The star collapses in on itself. Sometimes it explodes as a supernova, lighting up the galaxy and creating elements like gold and iron. Other times, if it's heavy enough, the collapse doesn't stop. Gravity crushes it so completely, the star disappears into itself, leaving behind a black hole. And that's where the real horror begins. So what exactly is a black hole, and why does it scare even scientists? The black hole, the universe's trapdoor. A black hole is a place where gravity is so powerful, not even light can escape. Cross its boundary, called the event horizon, and you're gone forever. Planets, stars, even entire clouds of gas can be swallowed whole. To us, it looks like a patch of pure darkness in space. What happens inside? Nobody truly knows. Some scientists say matter gets crushed into an infinitely small point. Others think entire new universes could be born beyond that boundary. But one thing is clear. Black holes are the most mysterious objects we know of, and they make even the mightiest stars look fragile. And this brings us to the big question. From fear to hope. The same science that gave humanity the hydrogen bomb is also what lets us understand stars, galaxies, and the universe itself. Some people call astronomy useless, but it's astronomy that helped us figure out the forces that power the sun and the dangers hidden in massive stars. Without it, we wouldn't know what black holes are or how fragile our planet really is. The irony? The same knowledge that created the deadliest weapons could one day save us when Earth can no longer sustain life. The real question is, will science remain a weapon, or will it be our hope? The universe is bigger, darker, and stranger than we can imagine. From our calm little sun to colossal stars that collapse into black holes, every star's story is a lesson about life, death, and power. And what comes next? That's a mystery we're still chasing. So think about this. What would happen if tomorrow a massive star near us exploded?